Welcome to Group 2's presentation on Loaf. This presentation will cover Loaf's business model, the strategic value of IT to Loaf, an ER diagram based on Loaf's website, our Microsoft Access database, an SQL query, and recommendations for website improvement. Charlie Marshall founded Loaf, which originally started out as thesleeproom.com in 2007 after discovering the difficulties consumers had buying beds. Loaf began as an online retailer, but in 2015 opened up their first store in Battersea. After the success, Loaf opened 2 new stores in Notting Hill and Spitalfields. Selling both online and in-store means that Loaf are able to appeal to a wider percentage of the market. However, as an online retailer, it can be argued that Loaf target a young audience of homeowners in the middle to higher social class market, as the older generation are perceived to be less familiar with the use of the internet. Loaf's value proposition is based around performance due to the focus on the quality of their products through unique designs of their furniture. It is incremental because they are adding new features and attributes to their products. Therefore, they are satisfying a customer need rather than creating new technologies to solve an issue. Currently, Loaf use delivery couriers including Wincanton for larger deliveries and DPD or Parcel Force for smaller deliveries. Loaf create personal relationships with established businesses such as Lloyd's, who are now responsible for all card net transactions for the company. In the past year, Loaf has paired up with department store John Lewis, selling exclusive products to customers. This illustrates that Loaf are slowly expanding by building relationships with big businesses while still sticking to their values. Loaf also upload blogs about different occasions where certain furniture products would be ideal. This enables them to continuously communicate and create relationships with their customers. Loaf's revenue stream is made of transaction revenue as they gain money from service sales rather than any usage fees or subscription fees. They can create high margin revenue due to them creating high quality products, and their prices don't change as no negotiations can take place due to them being a predominantly online retailer. IT can be defined as the hardware and software technologies a firm needs to achieve its business objectives. IT helps overall business performance by promoting synergies and core competencies. Loaf invested in IT by designing a custom-made system which enables valuable data analysis. The hands-off matrix suggests Loaf used a market penetration strategy by introducing existing products into existing markets with an emphasis on an online presence. In becoming an SME, Loaf used IT to upgrade its system and enable the processing of more information. D3R have had a 5-year relationship with Loaf, helping with efficient web design and providing a seamless customer experience. According to Porter's 5 Forces, this helps with rivalry against existing competitors. IT can increase barriers to entry by making the industry more efficient, leading to a lower threat of new substitutes for Loaf. The intangible benefits of increased effectiveness and flexibility have been enabled via Loaf's content management system, which allows customers to track orders. Also, Loaf's image app automatically assigns images to the correct product, making information valuable. Using IT also has strategic value to Loaf in achieving tangible benefits like sales targets. Social media platforms like Facebook increase communication with customers. This results in an effect in terms of search engine optimization, brand awareness, and sales. The value chain analyses the firm's internal activities to establish which activities are most valuable in providing a competitive advantage. In the retail industry, digital disruption in the form of the proliferation of multi-channels affects the way people do business. It can be identified from Porter's 3 generic strategies that Loaf used a focused differentiation strategy by concentrating on a niche market with a unique selling point of high-quality products manufactured by independent, family-run businesses. An entity relationship diagram is a methodology for documenting databases, illustrating the relationship between various entities in the database. An ER diagram was created for Loaf using the main entities found on the company website when placing an order. The most important entity that was first identified was the customer, because this is the most integral part of the ordering process. The next step in the ordering process would be the customer placing an order, which is why the second entity is that of order. One customer can place many orders, and one order will always have one customer, which can be defined as a one-to-many relationship. Payment is the next entity that has a relationship with order. It has a one-to-many relationship in that one customer's payment can be linked to multiple orders, and one order will always have a payment. Another entity which has a separate relationship with order is courier, where the relationship is a one-to-many. One courier always distributes one or many orders, and one order has one courier. The next stage would include the entity line item, which specifies the number of products in an order. An order placed can have one or many items, while at the same time a line item is always part of one order, hence being a one-to-many relationship. Further in the process, the entity product can be added. The relationship here is a one-to-many relationship. A product can have one or many quantities, while a line item will always refer to one product. The category entity has a relationship with the product entity, in that each category will always contain multiple products, and Loaf's products will always fall into one category. The final step in the order process is the entity supplier, which has a one-to-many relationship with the entity product. One supplier will always supply one or many products, and each one of Loaf's products come through one supplier. As you can see here, the primary keys are underlined and were used to construct the database. A database is a collection of data organised to service many applications at the same time by storing and managing data so that they appear to be in one location. Here you can see the relationship between all the entities in the database. The design of the database matches the ER diagram which was created for Loaf. The database includes 8 entity tables, 1 lookup table as well as 1 query. The customer table is used to record all the information required on Loaf's customers, such as email addresses. 10 samples of customer data were recorded here. The order table includes all the details that Loaf would need for customer orders. It has information such as the date the order was shipped as well as the total price of the order. Here, the primary key is order ID. The table also has foreign keys, customer ID to link it to the customer table and billing ID to link it to the billing table. The payment table has each customer's billing information with details like the date they were billed, as well as specific information regarding the card they used to pay for the order. Once again, the customer ID is a foreign key in this table, so that it can be linked to other information on the customer in the customer table. The courier table shows 10 records of orders delivered through the 3 couriers that Loaf use. Order ID is a foreign key so that the courier is able to access more detailed information regarding the customer's order. The line item entity is shown here in the T_item table and was created to break up the many-to-many relationship between the order and product entities. This table includes multiple foreign keys, order ID and product ID, as these closely relate to the quantity needed for each order. The product table is very useful for Loaf as it contains details on all the products they sell. Here, 10 of their products are displayed from a variety of product categories on their website. This table includes information like the price of the item. Category ID is a foreign key here, which links the product to the specific category it belongs to, shown in the category table. Another foreign key is style. A lookup table was created for the style attribute in the product entity to improve the efficiency of the data process. Creating this as a lookup table enables products to be filtered by every style on their website. Another table was made for all of Loaf's product categories. The last table contains all the information on the suppliers that Loaf use, including their contact names. Category ID is a foreign key here to show what category the supplier's products fall under. Querying is the process of retrieving data from an R table. Structured Query Language, SQL, will be used for the querying process. This is the standard data manipulation language. In this hypothetical query, a young female would like to buy herself a new bed. However, she would like the bed to be made out of metal. This SQL will show how the website would process this request. The customer would first select the beds category on the website and then filter the style to metal beds to find her ideal product. The only product available in this category is the beatnik bed. There are many recommendations for Loaf to improve the interface of their website. First, improve the speed customers experience when loading and accessing the online site. Second, enhance accessibility for users with disabilities, for example by reviewing their colour scheme for users with visual impairments. Third, develop a function on their interface to allow customers to create an account with Loaf. Thank you for watching Group 2's presentation on Loaf. We hope you have enjoyed it.